So 5.2, we're going to discuss how we can use this unit circle to help us. And it says, recall that the unit circle is a circle with a radius of 1, whose center is at the origin of a rectangular coordinate system. On this unit circle, let theta be the angle measured from the positive x-axis to the point xy. Okay, and since theta can be any angle, we can see that point P can be found on for some basic angles. And so what I mean by that is here's just a visual of us giving you the unit circle, and I'm not giving you a specific angle there. It's just some random angle. Well, I'm going to go ahead and pull up the unit circle. And this is what you're going to do when you're doing your homework, okay? You're going to have this out however you see fit, printing it or handwriting it while you do your homework, because it's going to help greatly. So it says, if theta is 180 degrees, what is the coordinate? Well, I'm going to find 180 degrees, and my coordinate is -1, 0. If it's 270 degrees, so I'm here, my coordinate is 0, -1. All right, now I'm going to go to 90. My coordinate 0, 1. 360, remember that's one full revolution, so it's coterminal with 0. 1, 0. Well, 0 degrees is the same value because it's coterminal. -90, remember, we talked about this in the previous lesson. -90, I go clockwise. I'm going to go hit here. Okay, well, it looks like my coordinate is 0, -1. Okay, well, now I'm going to go ahead and get rid of this just so. I'm going to go here. Now, the important thing is when we are in the unit circle, we aren't always, but when we are, what happens is this means our hypotenuse has to be 1 unit, hence the unit circle, right? That's telling me my radius is 1. So if I know this, here's my right triangle, very similar to how we created the unit circle in previous videos. I'm going to go ahead and bring this right triangle out so it's just bigger and easier to play with. I have no idea what this theta is. It does not matter. I do know that this is x and this is y. And I do know, since I'm on the unit circle, key thing, again, I'm going to make this stand out, I do know my hypotenuse has to be 1. So if you're standing at theta, to bring in some chapter 7 material, if I'm standing at theta and say I want to find x, okay, well, isn't x adjacent to the theta? And I'm given the hypotenuse. Well, ask yourself which one deals with adjacent and hypotenuse. Well, that would be cosine theta equals adjacent over hypotenuse. Well, what is anything divided by 1? It's just itself. Okay. Now I'm going to try to find y. Well, y is opposite of theta, and I'm given the hypotenuse. So ask yourself, what definition dealt with opposite and hypotenuse? So that's sine of theta equals opposite over hypotenuse. Well, anything divided by 1 is just itself. And so what we're finding here, this is the key thing though, it's only when we're on the unit circle, when our denominator is 1, is that when we're on the unit circle, now all my x values actually represent my cosine values of that angle, and all my y values represent sine of that angle. And this is super important because this is how this is going to come into play, kind of like multiplication tables. Because now I could figure out sine of 60 degrees easily. I don't need a calculator anymore. I am just going to refer to my unit circle. So what I'm going to do is I'm going to pull up that unit circle again. And let's go ahead and not make it so messy. Let's go ahead. There we go. I'm going to bring it down here. Okay, I'm going to erase this stuff that we did. Oh, it's not going to let me because I saved it, but it's fine. Sine of 60 degrees. I'm going to find 60 degrees. Well, I'm on the unit circle. So my x value are my cosines. That's what we just figured out up here. And my y values are sines. There's something that happens with students, and I think it's because of how we teach SOHCAHTOA and sine comes first. So students always think the x value is sine. Realize the x value is always cosine and the y value is always sine. So sine of 60 degrees, I know then, will be root 3 over 2. It's pretty great. Now you don't have to figure things out. It won't take you as long. And you can use your calculator to see if that's accurate, and it is. So cosine of 2 pi over 3. Well, now I'm going to find 2 pi over 3, which is right here. And my cosine, remember, is your x value. That would be negative 1/2. I'm going to move this. Let's see. Come on. There we go. All right. Sine of 360 degrees. Well, here's 360 degrees. Remember, it's one full revolution around your circle. Again, just to remind you, I go once around. Okay, well, I'm looking for, was it sine or cosine? Sine. And so that's why it'd be 0. Cosine of 2 pi, you're in the same location, but it's your x value, so it's 1. Sine of 3 pi over 2, well, that's going to be negative 1. And maybe you want to pause this video and see if you can figure out the rest to make sure it's clicking. Cosine of 270 degrees, well, I'm still here, and cosine would be 0. Sine of 45 degrees is here. Well, sine would be root 2 over 2. Cosine of 45 degrees, root 2 over 2. Sine of 90, 1. Cosine of 90, 0. And now it's asking for negatives. So negative 90, remember, we're going to go this direction. And I'm looking for sine, so that would be negative 1. Well, cosine of negative 90 and negative pi over 2, right? So just negative 90 and negative pi over 2, that's the same location. I'm just using different units. It's like using feet or inches. Well, cosine of negative 90 is going to be 0. Okay, see you next time.